everyone, this is Kalpana here. In this video we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem. Solve d power 4 minus 2d cube plus d square into y equals to x cube. Firstly, let's find order and degree of the given differential equation. Identify the highest derivative. Here d power 4 is the highest derivative, so our order will be 4, and the highest power of the highest derivative is our degree. Degree is 1. Or just write the given differential equation as d power 4y minus 2d cube into y plus d square y equals to x cube. We know that d is a differential operator. Then d square will be d square by dx square. D cube is d cube by dx cube, and d power 4 is d power 4 by dx power 4. Now let's write d power 4y as d power 4y by dx power 4 minus 2 into, write d cube y as d cube y by dx cube plus d square y can be written as d square y by dx square equals to x cube. Here d power 4 y by dx power 4 is the highest derivative, so order will be 4, and the highest power of the highest derivatives are degree. Degree is 1. Now coming to the problem. Given differential equation, d power 4 minus 2d cube plus d square into y equals to x cube, which is in operator form. F of d into y equals to q, where f of d equals to d power 4 minus 2d cube plus d square, and q equals to x cube. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is yc is complementary function, yp is a particular integral. We'll find yc using the roots of auxiliary equation of homogeneous equation of the given non-homogeneous equation. Simply by taking RHS to 0, we'll get the homogeneous differential equation of the given non-homogeneous differential equation, and we'll find yp using 1 by f of d into q. Right? Here we have qx power cube, right? Let's compare with x power k. For k equals to 3, you'll get the values of q while operating d's till d cube of q. Okay? And from d power 4 of q, you'll get 0. Or you can say that d power k of q equals to 0 from k equals to 4, 5 and so on. Let's see. Firstly, we'll find yc. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d equals to d power 4 minus 2d cube plus d square, right? Let's replace differential operator by n, so that we'll get f of m equals to m power 4 minus 2m cube plus m square. Then our auxiliary equation becomes m power 4 minus 2m cube plus m square equals to 0. Now let's take m square common from all the three terms of LHS. We'll get m square into m square minus 2m plus 1 equals to 0, right? See, these terms you're having m square minus 2m. You can write this 2m as 2 into m into 1, right? And plus this 1 can be written as 1 square, which is of a square minus 2ab plus b square form. We can write it as a minus b whole square, right? Now, we can write this m as m into m and m minus 1 whole square as m minus 1 into m minus 1. Now equate each factor to 0. Then you'll get m equals to 0, m equals to 0, m minus 1 equals to 0, m minus 1 equals to 0. Right? Already you're having m equals to 0, m equals to 0, 0, 0 are the roots. And from m minus 1 equals to 0, you'll get m equals to 1. And from this also you'll get m equals to 1. So from this you'll get m equals to 0, 0, 1, 1. Which are the roots of our auxiliary equation. Therefore, m equals to 0, 0, 1, 1 are the roots of our auxiliary equation, which are equal, right? You have two pairs of equal roots. Which are a pair of equal roots, right? We know that when two roots say m1 equals to m2 are equal, then our complementary function will be c1 plus c2x into, if two roots are equal, you will get two terms under brackets, right? Into e power that equal root into x. Now let's write firstly for two equal roots, for 0 and the next equal roots 1. A complementary function looks like y is equals to c1 plus c2 x into e power equal root 0 into x plus another constant c3. Already we have used c1 and c2, so I'll take c3 and c4 here. c4x into e power other equal root 1 into x. Which is equals to c1 plus c2x into e power 0 into x is 0 plus c3 plus c4x into e power 1 into x is x. This becomes c1 plus c2x. We know that e power 0 is 1, right? So you get into 1 plus c3 plus c4x into e power x, which is equals to c1 plus c2x plus c3 plus c4x into e power x. Therefore, y is equals to c1 plus c2x plus c3 plus c4x into e power x. Now let's find yp. Particular integral. We'll find particular integral using 1 by f of d into q, where f of d equals to d power 4 minus 2dq plus d square, and q is x cube. Now let's take d square common from all the three terms of denominator. We'll get d square times d square minus 2d plus 1 into x cube. Now let's split the fraction as 1 by d square into 1 by d square minus 2d plus 1 into x cube. Now this is d square, right? 1 by d square into 1 by, let's write this denominator as, we'll consider d square minus 2d as one term and 1 as another term. Okay, then we can write this as 1 plus d square minus 2d, right? Nothing has changed, into x cube is equals to 1 by d square into, we can write 1 by 1 plus x as 1 plus x whole inverse, right, into x cube, let it be. Now we are having yp equals to 1 by d square into 1 plus d square minus 2d whole inverse into x cube. Now let's find derivative of x cube. Derivatives, I can say. Derivative of x cube is 3x square and d square of x cube is derivative of x cube. We already have derivative of x cube is 3x square, right? From this we'll get 3 into derivative of x square, which is equals to 3 into derivative of x square is 2x, which is 6x, right? Now find d cube of x cube, which is equals to derivative of d square of x cube. We have the value of d square of x cube, which is 6x. Now we can write it as derivative of 6 into derivative of x is 1. 6 into 1 is 6. Now let's find d power 4 of x cube. Equals to derivative of d cube of x cube, which is equals to derivative of, we have the value of d cube of x cube, which is 6, and we know that the derivative of a constant with respect to x is 0, so we'll get 0. Likewise, d power 5 of x cube, d power 5 of x cube, d power 6 of x cube, and so on becomes 0. So it is clear that d power k of x cube equals to 0 from k equals to 4, 5, 6 and so on, right? 4, 5, 6 and so on. Here, if you notice in cube we are having x cube, right? Then for k equals to 3 till you'll have derivatives till k equals to 3. Okay? 1, 2 and 3. That's it. And we'll neglect higher powers from d power 4. Right? Just remember this. Right. Now, we'll use binomial expansion to expand 1 plus d square minus 2d whole inverse. We know that 1 plus x whole inverse equals to 1 minus x plus x square minus x cube plus so on, right? Then 1 plus d square minus 2d whole inverse becomes 1 minus d square minus 2d plus d square minus 2d whole square. Just compare the 1 plus d square minus 2d with 1 plus x, and for x equals to d square minus 2d, we'll just apply this formula, right? Minus d square minus 2d whole cube plus so on, right? So this equals to 1 minus d square minus 2d plus expand d square minus 2d whole square using a minus b whole square formula, which is a square plus b square minus 2ab. Then we'll get d square whole square plus 2d whole square minus 2 into d square into 2d minus expand a minus b whole cube using a cube minus b cube minus 3ab into a minus b formula, right? We'll get a cube d square whole cube minus b cube 2d whole cube minus 3 into a into b into a minus b, right? Plus so on. Then 1 plus d square minus 2d whole inverse becomes 1 minus of d square minus 2d plus d square whole square, which is d square into d square, d power 2 plus 2, which is d power 4, right? D power 4 plus 2d whole square is 2 square 4 into d square minus 2 2s are 4 d square into d is d power 2 plus 1 d cube, right? You'll get d cube here. Minus of d square whole cube is d square into d square into d square, which is d power 2 plus 2 plus 2 d power 6 minus 2 cube d cube. 2 cube is 8 into d cube minus 3 2s are 6 d square into d is d cube into d square minus 2d, right? Plus so on. See, here we have used only 1 minus x plus x square minus x cube, because we know that higher terms from power 4 becomes 0, right? That is d power 4 of x cube is 0. Let's see what happens now. This becomes 1 minus of d square minus 2d plus d power 4 plus 4d square minus 4d cube minus of d power 6 minus 8d cube minus into plus minus 6 d cube into d square. D power 3 plus 2 is d power 5, right? You'll get d power 5 minus into minus plus 6 2s are 12 d cube into d is d power 3 plus 1 d power 4. You'll get 12 d power 4 plus so on. Now, we know that while operating x cube to all this, we have values for cube, d square, d and d cube, right? We don't have values, we'll get zeros for d power 4, d power 5, d power 6 and so on. So you can neglect the higher powers from 4, right? So you can neglect d power 4, d cube, d power 5 and d power 4, right? So now, coming to yp is equals to 1 by d square into, let's write the expansion here, 1 minus of d square minus 2d plus d power 4 plus, okay, before writing this expansion you need to add one more step, right? Is equals to 1 by d square into, we need to write the expansion of 1 plus x whole inverse 1 minus x plus x square minus x cube plus so on. 1 minus x plus x square minus x cube plus so on into cube, x cube. Okay, we know that the higher order terms from here become 0, so we are not taking these terms here. Is equals to 1 by d square into 1 minus, now write this step, d square minus of d square minus 2d plus d power 4 plus 4d square minus 4d cube minus of d power 6 minus 8t cube minus 6d power 5 plus 12d power 4 plus so on into x cube. Now you can neglect higher order powers or you can just go with the flow, right? But I'll write it here. D power k of x cube is 0 from k equals to 4, 5, 6 and so on, right? Now you can neglect the higher powers here itself. This is square. 1 by d square into 1 minus. So what are the terms to be removed? D power 4, d power 6, d power 5 and d power 4. Then we'll get 1 minus of d square minus 2d plus 4d square minus 4d cube minus of only one term from d square minus 2d whole cube minus 8d cube, right, into x cube. Now this becomes 1 by d square into 1 minus d square minus into minus plus 2d plus 4d square minus 4d cube minus into minus plus 8d cube into x cube. This becomes 1 by d square into 1 plus 2d minus d square plus 4d square is plus 3d square and minus 4d square plus 8d square is minus 4d cube plus 8d cube is plus 8d cube into x cube. Now this becomes 1 by d square into 1 into x cube is x cube plus 2d into x cube plus 3d square into x cube plus 4d cube into x cube, right? This becomes 1 by d square into x cube plus 2 into derivative of x cube is 3x square plus 3 into d square of x cube is 6x plus 4 into d cube of x cube is 6, which is equals to 1 by d square into x cube plus 2 3s are 6 x square plus 3 6 are 18x plus 6 4s are 24. Now we need to operate 1 by d square, right? We can write it as 1 by d into 1 by d into x cube plus 6x square plus 18x plus 24. This becomes 1 by d into operate 1 by d firstly to all these 4 terms, 1 2 3 4, integral x cube dx plus integral, which is nothing but 1 by d, right? One by d of x cube plus 1 by d of 6x square plus 1 by d of 18x plus 1 by d of 24, which is equals to 1 by d into integral x cube dx plus 6 integral x square dx plus 18 integral x dx plus 24 integral dx, which is equals to 1 by d into integral x cube dx is x power 4 by 4 plus 6 into integral x square dx is x cube by 3 plus 18 into integral x dx is x square by 2 plus 24 into integral dx is x. 3 ones are 3 twos are 2 ones are 2 nines are. This equals to 1 by d into 1 by 4 into x power 4 plus 2 into x cube plus 9 into x square plus 24x. Now let's perform 1 by d. We'll get 1 by d of 1 by 4 x power 4 plus 1 by d of 2x cube plus 1 by d of 9x square plus 1 by d of 24x. Okay, now let's write 1 by d as integral by taking constants outside the integral. Since 1 by d is an integral operator, right? 1 by d is a integral operator. We'll write the constants outside the integral and write this as constant 1 by 4 into integral x power 4 dx plus constant 2 into integral x cube dx plus constant 9 into integral x square dx plus constant 24 into integral x dx, which is equals to 1 by 4 into integral x power 4 dx is x power 5 by 5 plus 2 into integral x cube dx is x power 4 by 4 plus 9 into integral x square dx is x cube by 3 plus 24 into integral x dx is x square by 2, right? 2 ones are 2 twos are 3 ones are 3 threes are 2 ones are 12s are. This is equals to x power 5 by 4 5 is 20 plus x power 4 by 2 plus 3x cube plus 12x square, which is our required yp. Now let's write the general solution. We know that the general solution is given by y equals to yc plus yp. Then our solution looks like y equals to c1 plus c2x plus c3 plus c4x into e power x plus yp x power 5 by 20 plus x power 4 by 2 plus 3x cube plus 12x square, which completes the problem. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.